Hello and welcome back to Climbs Unboxed. Now today I want to talk about seasons. Now not these kinds of seasons, we're going to be talking about seasonal cycles or also how to calculate diurnal cycles, averages at an hourly time resolution. So what exactly do we mean by this? Well, let's start with a simple example. Over here on my left hand side you can see an example data set that spans 2 years with data at a monthly resolution. Now, of course, you will usually be dealing with data sets that span multiple years. This is just an illustration. Now, what we might want to do sometimes is calculate the seasonal cycle, and that means essentially we want to take all of the Januaries in our data set and average them. So in this case, we only have 2 Januaries, but of course you might have a 10 or 20 or 100-year data set with many, many Januaries, as I've illustrated here. And so what we want to do is average all of those. Now, with the CDO commands we've already learned, we could do this by selecting the specific month from the data set. So we can select all the Januaries by saying CDO cell mon, comma 1 for the first month, input output, and that basically selects all the Januaries into one file. And then we can use a mean function such as time mean to average all of those Januaries. So that way we've extracted all the Januaries and we've averaged them. We could carry on and do this then for all of the Februaries and all of the Marches. Eventually we have a whole series of files. And then of course we need to merge these using merge time. This is very long and convoluted. Luckily for us, we don't need to do this. We can actually use a built-in command that allows us to calculate seasonal cycles and also diurnal cycles. So let me show you this now. So the command is basically made up of 3 components. So let's take a look at these now in turn. First of all, we can see that the cycle is the period over which we're averaging. So if we have a seasonal cycle, we're averaging then over years. On the other hand, if we're looking at a daily cycle, or we want to know the averages over the hour 1, hour 2, hour 3, then we're averaging over a cycle of days. The annual cycle is a cycle over years, and so we abbreviate that by the letter Y. Instead, the averaging cycle over days is D. Okay. Now the averaging period is the period over which we want to split up that cycle. So for example, the year could be divided into days, or it could be divided into months, or we can even divide it into hours. And lastly, we have the actual function we wish to apply. The common functions we usually will be using are mean, max, min, standard deviation, or variance. So instead of calculating the average, we can calculate the standard deviation to give you an idea about year-to-year variability instead of just the average climate. So let's look at some examples now. So the first example is calculating the mean seasonal cycle over many years. So as we're calculating over a cycle of years, we abbreviate year by the letter Y. So the command has the first component, Y. Now in this particular example, we want to have an averaging period of months. So our final output will have 12 steps, average January, average February, average March. And so the monthly averaging, if you remember our abbreviation from the earlier video, was MON, M-O-N. And last of all, our function is the mean. So the command that we need is Y-MON mean, which means we calculate the average of all of the months over a cycle of years. Now, then we have the input file and the output file. So the input file is simply our original file, which has monthly time series data over multiple years. Now I should mention that you don't have to have monthly input data. You could actually have daily data over 10 years as an input, and this function would then take the average over all of those days within the month and then average over the months. So you could actually give an input file which was 10 years of daily data, and the output would then be the average seasonal cycle at a monthly resolution. The next example then is a mean seasonal cycle, but now at daily resolution. So the only difference in this command, we still have a cycle that's over years. So we start the command with Y, but then we have an output which is going to be at daily resolution. Now, needless to say, in this case, you'll need to have an input file which has at least a daily resolution, or hourly, or even finer. You won't want to pass a monthly resolution input file and expect it then to extrapolate that temporal resolution down to a daily step. Now, the last example, we can look at the diurnal cycle. By using a diurnal cycle output, we now change the initial letter from a Y to a D. We want to average, in this case, over hours, so we have D hour mean. So this will take the input file, which may be just for a year or a couple of months, or it may span many years, and it takes all of the 0, 1, 2 hours, 3 o'clock, takes the hourly data and averages all of the steps at hour 0, all of the steps at hour 1, and then we'll give you an average diurnal cycle as an output. So let's see this in action, shall we? So I have a directory here with a number of files. At the top of this directory listing, we will see yearly files with a time resolution of hourly data. And underneath, there's another set of files which have been averaged to a monthly mean, or you can directly download them as monthly averages. I want to quickly show you the script I used to actually download this data here in Get Era 5. Now, in a previous video, and there should be a link popping out in the banner right above my head, I've already shown you how to use a Python API script to download data. The only thing that's perhaps a little bit unfamiliar is I've actually got an arrange command for S in range 1 to 13. So that gives me 1 to 12 as an output, as a number, which is converted then into a string. And that file gave me this list of output files: CDO, showtime, era 5, 1990.nc, and the output shows hourly resolution. So now if we want to calculate a diurnal cycle, it's very straightforward to do. We can calculate it simply for 1 year using CDO, and the cycle over which we're averaging is daily, so we need a D, and then we need hour because we're averaging for each hour, hourly output time resolution. And then the function we want here is mean, but we could use max or min. Era 5, and we will take one example year, and I will say diurnal, so this is the output file name, process one variable over 8,760 time steps. And now the output file diurnal NC is here. We can look at this, of course, using NC view. So here's that output file. We click on the variable name. You may have noticed in the retrieval file, I was only retrieving for a small portion of the globe based around the Gulf of Guinea and the west coast of Africa. Let's take a nicer color scale. And if we click on a point, get a time series, how many points do we expect? We expect to have 24 points. So this is the first time slice at 0, 0, 0, 1, 0, 2, 0, 3, and so on through the day. So each of these points is the average for that hour over the whole year of 1990, I believe I used. If we click on a land point, this is now the white line, so the red line was the point over the ocean, and we can see a much stronger diurnal cycle over land as we would expect, with a strong peak in the afternoon. So let's close that down and take another example. Now we want to do an average of the seasonal cycle averaged over many years. We have separate annual files. So one way is to merge all of these into one long file. So we're going to do that using merge time. And then we have era 5, year. And then you see when I press tab, it completed up to 19, at which point the file name becomes ambiguous. Now I could put in an asterisk.nc. Remember, that was the wildcards that could be replaced by any number of characters. Or we could be even more strict and put in a double question mark. Remember, if you're always worried about what files will be picked up, you can always test it with an ls to list, and it will list the files in the directory that will be picked up with that set of wildcards. So instead of listing now, we want to do cdo merge time. These are the input files, and then I'm going to call it era5 allyears.nc. And what's happened, now we've got an error, and I mentioned this earlier, because the data is packed, when it tries to put the files together, the different packing numbers where you have a scale factor and an offset are not compatible and it falls over. So what we need to do is convert the variables to a 4-byte float. And if you remember, we do this by doing the option -b and then F32 for a 32-bit floating point number. And yes, we will overwrite it. There we have it. We have the output file. So listing all the files in reverse time order. Here we have era5 all years, and we can see it's much larger than the input files, firstly because it's concatenated them all together in time order, but also because we are no longer packing the data. We have 4-byte floats as an output. So now we can do cdo, and if we want to have an average over all years, so we need a y for year. We want to average monthly time scale, so we're going to say mun, and we want to use mean again. This is our input file, and then we need an output file, which I'm just going to call ymunmean.nc. So let's let that run, and we'll see what we get as an output. ymunmean.nc. And again, it's still for the same region, of course. And when I click now, before we had 24 time steps, now we expect to have 12 time steps. And that's exactly what we have. So if we count through these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, each of these is the average for 1 month. So the first point is the average over all of the hourly and daily steps for the month of January over all of the years. So it's the average January value over all of the years. And so we have this seasonal evolution of temperatures. So if I click on an ocean point, or if I click on a land point, we can see that the seasonal cycle is rather similar over both land and ocean, completely different to what we saw when we looked at the diurnal cycle, of course. So that was an average over months, but we can do exactly the same thing with a daily output time step as well. So if I quit that and we go back, I'm going to cycle through the commands. Instead of now ymunmean, I'm simply going to replace mum by day. I want to change the output file name, of course, to something relevant. So we have ydaymean, and now we can look at the output file, ydaymean. And now when we click on one of these points, we still have the average seasonal cycle, but the output resolution is now daily. So the seasonal cycle is much more noisy because each of these points is only the average over, for example, all of the 1st of January's. So we have 24 hourly steps that have been averaged, and then each of the 1st of January's. But because it's only 1 day, of course, we still have quite a bit of day-to-day variability in this annual cycle. Also because we're only averaging over 1979 to 1992, which is a relatively short period. So in this video, we saw how to calculate diurnal and our seasonal statistics and seasonal cycles. I hope you found it useful, and I look forward to seeing you on Climate Unboxed again very soon.